Everybody. So I want to apologize for keeping everybody from ice cream for a little bit longer, but I hope you guys enjoy this presentation. I had a lot of fun putting it together. Hi, I'm Ellen. I work in Chicago for a company called Shapiro. We make it easier to find and reserve parking. I was planning to wear my Shapiro hoodie over my Hum shirt, which is my side project. This is a songwriting application that I work on with a guy named Aaron Sheeky, who's a designer at GitHub. And that plan went right out the window when it was like, let's see, I guess 80 degrees Fahrenheit inside. So that would be about 26 degrees Celsius. So I was like, maybe a hoodie is not the right choice. So in my work bringing a bunch of different applications to life, I've really gotten into testing, and I want to talk a little bit about the theory and the practice of testing, and specifically about the theory and practice of UI testing. So as with any kind of testing, or really any kind of code whatsoever, UI testing has its advantages and its disadvantages. And to help understand where I'm coming from on everything that I'm about to say, I want to start by talking about theory. It's going to make the practice stuff that I get to later in the talk make a hell of a lot more sense if I can give you an outline of why you would want to do what I'm proposing you should do in the first place. So today I want to talk about what happens when you take over an existing application, and specifically what happens when you take over an existing application with no tests. Like, dun, dun, dun! I've done this twice in the last year. Once in an app that I wrote a huge chunk of, which is Hum. And that was before I got into testing. So I was like, oh, yay, that was really not a good idea. And then again with Shapiro, where I just started about 2 months ago. And taking over an app, or even continuing an app that you had already started before you got into testing, when you're used to testing and you suddenly have no tests, this gets to be a very frustrating situation because you essentially wind up reading a Game of Thrones length amount of code to try and make sense of what is going on under the hood of the application. And while there are times you can sort of follow the plot, and sometimes it's not unlike Game of Thrones, where characters just wander around for entire books and their plot lines start to intersect in unexpected ways. And in the same way, you can wind up with all sorts of crazy dependencies where your pieces of code that you couldn't have even imagined would work together are now working together. You also start to see interesting things in code that you start to pick up on as signs. Hey, maybe this isn't the best code that's ever been written. You wind up having smart people, like our CTO, Larry, who are writing iOS code by the seat of their pants and have no idea what they're doing. And one good way that this is indicated is the my company name being left in as a placeholder. And to be fair to my CTO, I totally did this when I first started doing iOS code as well. So, you start digging through all of this code and you start looking at some of the Git commit history, and sometimes you find these very honest commit messages from your predecessor. They at least help you understand why some things are the way they are. And then sometimes there's a few things that are less helpful. This, I would say, was about 1,000 lines of code. So I was like, nice work. Especially when there are many developers on a project, you can get really deep into one piece of code, trying to figure out how it got there, and you just wonder who to blame. And sometimes you know exactly who to blame. Past me, always a way bigger idiot than I remember being. No matter who wrote the original code, the real danger of either continuing an existing app without tests or picking up an existing app without tests comes when you try to maintain that code or fix bugs in it. Because it's really, really easy to make a stupid mistake and not have it tested. Speaking of which, this is a snippet of our Slack channel from when I accidentally broke checkout in iOS 8 for a few days on Shapiro. I made this shamefully amateurish programming error, and it slipped through code review. And I had gotten far too used to having tests in my code that would catch me when I did something dumb. And I hadn't actually tested this thing on an iOS 8 device because our audience is right now about 95% iOS 9. I found out about this bug when I started getting crash logs all of a sudden, and then we started getting some very cranky phone calls from our users. And, when you're getting into code, whether you were the original author or somebody else was, your first instinct is to refactor it to make it suck less. But if you don't have some kind of safety net underneath you when you do that, you are almost certainly going to break something you didn't intend to. And so this is where I get to the title of this talk, which is Outside In. Most talks about testing start by talking about testing individual small little pieces of code and assume that you have this lovely greenfield project where you can architect everything well in the first place. In the real world, that very rarely happens. So when you start to look at how you can make your code more stable, rather than starting from the inside out and making sure each individual piece of code is very well tested and then moving it out to the rest of your application, it often makes much more sense to start testing from the outside of your app and then moving inward. And this is because ultimately, the most important question in app development is, does this work for the user? Can the person who is using my app actually accomplish what they are trying to do? Users do not care about how well architected your application is, how beautifully you've separated your concerns, how closely you have followed whatever architecture you have selected. Now, you as a developer care about that because you want to try and enhance and improve your app, and it makes your life much easier to have this kind of clean code. But how can you start to refactor but not break anything for the user? And so my argument is that you can do this by adding a scaffolding of UI tests around your app. So in Chicago, and I'm sure all the time here in Europe, there are a lot of older buildings that get bought by real estate developers to get turned into condos or apartments. And usually the owner wants to preserve the facade of the building, the front of the building, because either it looks really cool or it's really historic, but often the rest of the building really wasn't built terribly well. So they put up this scaffolding that holds up the facade, and then they just take a wrecking ball to the rest of it. So in the same way, UI tests can give you a really good way to hold up the front end of your app to make sure that it keeps working for the user, even when you start taking to a sledgehammer to everything under the hood. Now, one thing I want to try to clarify a little bit from a theoretical perspective before we move on to the practical perspective is, what do I mean by unit tests versus UI tests? How are they different? So I want to start by defining unit tests, because unit tests are really what most people think about when they think about testing. They're small, isolated test cases which can quickly check whether your code is doing a particular task correctly. And they're called unit tests because they're supposed to test a unit of code in isolation. And because they're so isolated, they can run really, really quickly. I've seen a suite of like 1,000 unit tests run in just a few seconds. And these are great, don't get me wrong. Like, I write plenty of unit tests, but when you're taking over an application that already exists, and particularly if it has a lot of spaghetti code, making it possible to even test in isolation often involves really significant rewrites, and it's really, really easy to break something when you're doing that. So UI tests are always looking at the user-facing side of your application. They're always verifying that your app looks or works the way that you want it to. And there's this entire other battle just within UI testing, and that's snapshot tests versus integration tests. And the question sort of comes down to, what exactly are your tests looking for? Are they comparing old to new versions of your application and calling out any differences at a pixel level? Or are they looking to see that the user can tap through the application in a fairly specific fashion? Now, I personally don't have a ton of experience with snapshot testing, but at the moment, the real 500-pound gorilla of snapshot testing is FB Snapshot Test Case. It's a couple years old now, but Ornithorox has a really nice article on Objective-C.io about how to get started with it. It'll be in the links at the end of the slide deck. Now, I don't necessarily recommend this as a place to start. I think snapshot testing is really cool, and I'd really actually like to get into it quite a bit more, but in the end, I tend to care less about pixel perfection than I do about usability. And this is why I usually start with integration testing. So integration testing in general refers to checking that multiple units of code work together in the intended way. Not just, does this network call get me the expected response, and does this dictionary parse into this object as individual pieces, but when I make this network call, do I actually receive the correct object back? So when you're doing the type of UI testing that's considered integration testing, you're essentially telling the system to tap around in your app and verify that whatever is supposed to be happening is actually happening. So this isn't necessarily an integration test because it's making sure that every single piece of your application works together to make everything that needs to show up on the screen show up when and where it's supposed to. So this is an awful lot more time consuming than unit testing, because as you'd imagine, spinning up UI takes time, as does tapping through the application one thing at a time. However, this is a really, really great place to start, because you're always answering the question of, is this actually going to be helping the user accomplish what they're trying to accomplish? And with that, I want to get into a little bit of talk on the practice of UI testing as I practice it. So now that we're on the same page about what I actually mean by that, how do you actually do this in the real world? So there's two main frameworks that you can do this with right now. I'm going to talk about both XCUI and KIF. They both have their benefits. They both have their drawbacks. XCUI was introduced by Apple at last year's WWDC. It is baked into Xcode 7. It works with iOS 9 and above and El Capitan and above for Macs. The biggest thing that XCUI has going for it is that Apple built it. It is a first-party solution to testing user interface. You don't need to add any outside code to use it. And it's this officially blessed solution to UI testing. But one really key thing to be aware of is that Apple built XCUI on top of UI automation, which was the JavaScript framework that they used to use for a lot of UI testing. And a lot of people hear that and go, wait, JavaScript? And the reason that that was the choice when it was originally built was that the originally intended audience was QA automation engineers within Apple. And QA automation engineers could way more easily learn JavaScript than they could learn Objective-C. And they could use all of the built-in support that the UI accessibility frameworks have for automation, so that they could tell the UI automation framework to say, okay, click on the element with this accessibility label, so that they don't have to code very specific points that the application was supposed to be tapping into their tests. And this led to a lot of good things. You were able to make sure that your test code knew absolutely nothing about your application's code, and it allowed Apple to put together a really cool thing called the test recorder with the release of XCUI. And this actually generates Swift or Objective-C code as you tap through the application within your test. That's really neat. The problem comes with the way that all of this runs. So because QA folks don't need much, if any, visibility into the application itself, tests are in one process and the app is in another. And this is one of the many problems that I have with XCUI right now, because what this means in practice is that mocking is impossible. You can't pass mock objects into your app from your test because your test code has no idea how to access the running application code. And in order to pass any information into the test process, you have to pass it as part of a launch command, and then you can only pass strings. So what this winds up meaning is that you wind up having to write code that handles this launch information within your main application package, which can do anything from be really annoying to be kind of dangerous, depending on exactly what you're trying to test. The other big problem with XCUI as it currently stands is that it currently terminates and restarts the application for every single test. I don't mean every single test suite, I mean every single test. And so how bad is this? So this is a video that I took of a small set of tests that I put together for a small sample app that I did for RW DevCon a few weeks ago. So there's 8 UI tests in this, and all of them are extremely simple. This takes about 1.5 minutes to run. So if you imagine this scaled up to an app the size of Spot Hero, which has credit card entry and user sign up and all sorts of map stuff, or even Hum, which has a lot of different configuration options around sharps or flats or naturals and all that kind of thing, it would take forever and a day to test anything. So that is really, really frustrating. So there's another option out there, which is KIF. So KIF was originally built by Square. The name is short for Keep It Functional, but I will always use it as a Futurama reference. So Square originally released KIF in 2011. And at that point, UI automation with JavaScript was really the only option for testing the UI of your app. So having something that actually worked with Objective-C at that point was really revolutionary. And over the last 5 years, it's evolved to work with every single subsequent release of iOS. And KIF tests are set up in the same vanilla XC test case subclass. So basically, you subclass KIF test case, which subclasses XC test case, and you're able to actually compile and run everything in the same process as the main application. And what this means is that mocking and other forms of dependency injection are super simple, which helps you keep your test code and your mock objects living only in the code of your test package. And because it's been around since before XC test case even existed, there are even old forks of XC test case, or excuse me, of KIF, which allow you to just send test case if you really, really, really don't want to move to XC test case. And right now, the current XC test compatible version supports all the way back to 5.1, iOS 5.1, not Xcode 5.1. That is a pretty much unheard of level of backwards compatibility in the iOS world. KIF is also open source, which means that if you find something that's broken or doesn't really work the way that you like it to, you don't have to file a radar and then wait for Apple to deal with it. You can open an issue or pull request right on the KIF repo. A really good example of this comes from everybody's favorite UI kit bug whisperer, Peter Steinberger, who's hiding in the audience somewhere. He got really frustrated with how long it took his KIF cases to run, so he built a method that facilitates running all of the animations in your application at what he refers to as ludicrous speed, and to make your UI tests go way, way, way faster. And he opened a PR to KIF after he did this, and it was merged about 3 weeks ago, and now everybody has access to this. So thanks, Pete. That's the good news. So that's the good news. The bad news is that in the under-the-hood implementation, KIF uses a ton of private APIs. So you have to be really careful not to accidentally include KIF in your non-test code. So this is way easier now that CocoaPods exists. I remember when it really wasn't as much of a thing, and it was a huge pain. But you do have to be very careful about it, because if the KIF code winds up in your main app binary, that's pretty much an instant rejection from the App Store. So one downside of KIF's backwards compatibility is that there is a whole lot of code that you sometimes have to dig through to figure out what exactly is going on when something's going wrong. And there's probably a fair amount of it that could go away if they dropped support for older operating systems. So it's a little bit of a double-edged sword. For me, the biggest downside that I've found has been that KIF can sometimes have inconsistent results, especially when there are pieces of functionality that take different amounts of time on different hardware. Continuous integration kind of exacerbates this, since most remote continuous integration services like Travis and Circle run on a virtualized environment using a single processor. And sometimes this can actually help you by revealing something where it's like, oh yeah, I was kind of counting on the 4 processors that are in my Mac running on the simulator instead of whatever hardware the user is using. Far more often, it just gets very frustrating, and flaky tests are not super fun. I was talking to someone earlier, and I apologize, I can't remember who it was, but who said that when they had a KIF test fail on Travis, they would ask the person to run it locally, and if it ran locally, they were like, good enough. And that's not really a great solution, but it's definitely something where, in terms of the trade-offs, that's sometimes you got to do. So, in terms of those trade-offs, you might be wondering what I do. And the answer, as with everything in programming, is, well, it depends. For simple apps, I actually really like XCUI. Anything where you just want to make sure the damn thing works and where it doesn't have dependencies on time or date or network that will fail my builds because they've changed. For more complex apps, I personally still prefer KIF. Keeping my test code out of my shipping application is really important to me. And right now, there's just not a good way to do that with existing XCUI tests. And I'm really hopeful that Apple will be introducing some improvements in a few weeks at DubDub. I know those of us who use this, especially myself, have been filing radars one after another. I actually had one about the test running in a separate process close as a dupe within 16 hours. And you know, I've been annoying the crap out of the DevTools team members that are on Twitter, so like, hi guys, how's it going? Hope you're working on it, thanks. I'm really excited to see what version 2.0 looks like. So once you've actually got all of this information, once you're actually starting to test the UI of your application, how do you get information about what is actually covered by your tests and what's not? So obviously, if you have like a really thorough set of user stories, that can be a really great guideline in terms of what still needs to be tested from a UI standpoint. But if you don't have that, or if it's a little on the thin side, there's a really, really, really helpful resource in code coverage. And it's a really wonderful assistant to your testing process because it really helps you cover your ass. What code coverage does is it tells you what parts of your application are tested, including how many times each bit of code was run during the test, and what parts of your application are not tested. So this is really, really helpful as you start to go down the rabbit hole of, okay, well, what should I actually test? Because often a really good place to start is, what haven't I tested yet? So in Xcode 7, collecting code coverage is really simple. Going to your scheme and selecting tests, and then using that lovely little gather coverage data checkmark that I'm sure you can all see in this very large screenshot. You know, this causes Xcode to collect data in a coverage format called LLVM-cov, and Xcode can actually read this directly. So after you've run your tests with that box check, you can go to the report tab in the left sidebar. It's like the speech bubble. on the far right-hand side, and then you select your run of tests, and then voila, you have actual visual information, not just about how thoroughly your entire app is covered, which in the case of Spot Hero, we have some room for improvement. But you also get far more granular information, like the percentage of each file which is covered, and even the percentage of each method if you open the flippy triangle. If you actually click through, you can even go into your code and see a new right gutter that shows you how many times a given line of code was hit. If you hover over that portion of the right gutter, if you have had something that was hit, in this case I had something that was hit 374 times, it's like, ah, yes, a lovely green background and tranquility. And if you hover over the portion of the right gutter where something is not covered, you get the angry red background of test shaming. And what you do with this information is up to you. In this case, this is basically checking a quick function that returns a nil instead of an NS null from a dictionary. And I'd probably write a unit test to cover this particular case. But often you look at the code that's not covered and you realize, oh, this is a guardlet that's covering some kind of case that should literally never happen. And is this actually a case that I need to prioritize testing over everything else in my application? Or is this something that I can come back to while still having this code coverage, be ready to understand, OK, I know that part isn't tested, but theoretically that should never happen. You can decide all of that. But one thing I always like to try to remind people of anytime that I talk about UI testing, because I feel like when I talk about UI testing, there are a lot of people here who sort of think, oh yeah, now that I've got this robot tapping through my application, I don't actually need people to test this application. Like, bye QA guys, you're fired. That is not the case, because while robots are really awesome, they can't replace human testers. Robots can actually catch a lot of things faster than human testers, which is why I'm a very, very strong advocate of thorough testing. But human testers are always going to catch much more stuff than it's really possible to catch with a robot, especially around stuff where you're interrupting the user, like axe pushing or getting a phone call or looking at the notification drawer. Robots and humans working together are really the best way to make sure that your app works for the user. They will never catch literally everything, but you have a way lower chance of shipping a showstopper if you've got both. Your human testers and your automated tests should complement each other. Have the robots do the boring part so that the human testers can focus harder on the weirdest bugs that come at you. And with that, I'd like to present the obligatory summary slide. I really want to emphasize that the UI tests that I suggest here, it's all about user-centric feedback. The other thing that they provide you is a safety net as you try to refactor your application to actually make it easier to maintain from a development side. It is so frustrating when you are just trying to make the app better and you wind up breaking something for the users, especially if you already have a decent-sized user base. Definitely recommend using XCUI for simple stuff and KIF for more complex stuff. There should still be a little asterisk like, as of right this second, hopefully this will change within a couple of weeks. Use code covers to help you figure out what still needs to be tested. And then, robots and humans, happy geeks for all. That's all from me. Thank you guys very much for listening.
Thank you very much.
I have any questions if we have time. So.
All right. Do we have any question?
I will not be offended if you all just want ice cream.
Come on. Yeah, all right.
Yeah.
OK. We used an application we did, which was kind of complex KIF. And I had the experience that it was not made for complex apps. So I don't know. For example, I had a picker with 2 components inside. And I think KIF can only handle 1 component at all.
So I think
there were a lot of features missing. So I don't know. Or I wanted to ask you why you,
So can I ask how long ago that you were using KIF that you ran into that limitation?
Excuse me?
So how long ago, how much time ago was that?
I think it was December.
December? OK. I might have to talk to you afterwards. I haven't run into that limitation. One thing that I have run into is dealing with date pickers, where if you select a date and it's after the current date, it gets all messed up and stuff. But I haven't had that problem with multiple date pickers, so maybe you and I can take a look at what's going on afterwards.
Yeah,
So.
my experience was good to work with, but it has a lot of holes inside when you have a complex app.
Yeah, absolutely. And I think any testing framework will always have some kind of hole in it. I think for me, one of the biggest advantages of KIF is that it is open source, where you can at least talk to other people about what those holes are, find out how people are working around those holes, and potentially write a patch for one of those holes. I think that's the thing that's been most frustrating to me about XCUI, is that basically I'm firing radars off into the ether, and just like every once in a while I'll actually get one closed as a dupe, but otherwise I never hear back. So it's something where I think you have to think very hard about, okay, what are the pieces that are most important to me? And if you're running into problems with that, like I'll be happy to sit down with you afterwards.
Of course, yes.
Yeah, thank you.
Thank you. Any more questions? You all want ice cream, right?
I want ice cream.
All right, so we have different options. It is upstairs, and we even have a vegan gluten-free. All right, so then enjoy the ice cream.
Thanks, everybody.